Hi guys, last round of notes for this week of our remote learning experience. So we have taken a look at scientific notation, exponent rules, we've looked at square roots, we just took a look at cube roots earlier. And all of those roots that we have worked with have been really nice, perfect ones. So this lesson is taking a look at roots, the number under the radicand, if it's not a perfect square. So again, remember if we were evaluating something like the square root of 9, we're looking for two numbers that are absolutely identical that we multiply together to give that. So the square root of 9 is equal to 3. But again, this is the lesson notes. What if the radicand is not a perfect square, right? So what if this was the square root of 8 or the square root of 12, something that's not a perfect square? We took notes last week on perfect squares. Again, I'm going to refer back to that table that we filled out. Those are all nice perfect squares from 1 to 20. So we're going to look at ones that are not perfect squares. So when we look at those numbers and we try to take the square root of them, they're going to give us irrational numbers. So remember, we defined irrational as a number that just keeps going on and on. There's no pattern to it. It never stops. So because these are irrational numbers, when we solve roots that are not perfect, like the square root of 2 or the square root of 3 or the square root of 7, it gives us this crazy decimal number. So really all we can do is estimate or round our answer. So we're going to take a look at a couple of different ways to represent this answer. We're going to look at estimating or rounding the answer to the nearest tenth, and we're also going to look at rounding to the nearest whole number, the nearest integer. Okay, so we're going to look at both of these. So the steps to estimate square roots when they are not perfect numbers. What we're going to do is find two perfect squares that this radicand, the number under the radicand, is between. And then decide if our decimal number should be bigger, smaller, or in the middle. We're going to kind of use a 1/2 as our reference point. And then we'll do a little bit of guess and check and multiply until we find the decimal that's the closest. So this is going to require a little bit of scratch work. So we're going to just take a look at a bunch of examples and kind of clarify those steps that we just talked about. So here are directions. Ask for us to estimate each root to the nearest tenth. So the square root of 38, okay, if I were to take a look, and I'm going to just kind of list out some numbers before 38 and after 38, the square root of 36 is 6. The next perfect square would be 49. Okay, square root of 49 is 7. So that's what they are. Square root of 38 is between. Okay, so now I'm going to take a look. The square root of 38, is that exactly in the middle of 36 and 49? Well, let's see. The difference between those 15 would be about 7. 43, square root of 43 would be about in the middle. Square root of 38 is actually pretty darn close to 36. So what I'm going to do is I'm going to take a guess. I think that my decimal number should be 6 point something. It's going to be less than 0.5. I'm going to try 6.2. So what I'm going to do is a little bit of scratch work here. Okay, so again, my scratch work, 6.2 times 6.2. Do my multiplication, 2 decimal places, 38 wow, that was actually a great guess. Again, we're rounding to the nearest tenth, so I would only look at trying 6.1, 6.2, 6.3. My first guess, 6.2, was actually really right on. It's a little bit above 38, but again, we are estimating. Estimating means getting as close as we can. So that number that I was wondering about, 6 point what? I actually just figured out that my answer to this would be about, I'm going to put not equal signs, but I'm going to put those wavy equal signs, which means approximately 6.2. So that's rounding to the nearest tenth. And then to the nearest integer, I'm going to say that this is about 6. So again, this is rounding to the nearest tenth, estimating to the nearest tenth, and this is estimating to the nearest whole number. Okay, so we're going to take a look at both of those as our answer. Square root of 53. So again, when I take a look at my roots, and again, you can always have this table out. So you can see 53 is between 49 and 64. So again, this table is super helpful. So square root of 49, square root of 64. I know that this is equal to 7. This is equal to 8. So again, where is 53? When I take a look at the difference between those numbers, well, the difference between 49 and 64 is about 15 units. So like half of that would be 7. So square root of 56 would be like halfway in the middle. Square root of 53 is a little bit less than that. So again, if this would be the equivalent of like a 0.5, square root of 53 kind of down in here. So I think when I use my guess, 7 point what? I think I'm going to start with maybe 7.3. Again, it's kind of a guess and check. 7.3 times 7.3. We'll do a little bit of multiplication real quick. Let's see, 51.9. 2 decimal places. Wow, my estimating skills are kind of right on today. It's because it's early in the morning. 53.29, we're looking for the square root of 53. So my answer, 7 point what? Actually, my guess was again pretty good to begin with. So it's approximately 7.3. Again, that's rounding to the nearest tenth. Rounding to the nearest whole number would be about 7. So you can kind of see that we're going to just continue with this pattern here. Square root of 99, square root of 227, 86.4, square root of 123. I'm going to jump to one of these down here that's maybe a little bit challenging. We'll take a look at this one, square root of 86.4. So again, looking at my perfect squares, square root of 81 and square root of 100, that's 9, that's 10. So again, 86.4. Let's see, that's probably about square root of 91 would be kind of in the middle here. That would be about halfway. So I'm going to try a little bit less than that. Maybe that's 9.5. Maybe try, I don't know, 9.4 maybe. I don't know. Let's give it a guess and see. 9.4 times 9.4. What do we get here? 88.36. That's a little bit high. I'm going to actually try another set of scratch work, see if 9.3 is any closer to that. Let's see, doing my multiplication here. Oops, the screen just went on screensaver mode. Sorry about that. Let's see. 14.6, 86.49. Wow, okay, so that is much better. So again, when I did my estimating 9 point what, my first guess was a little bit too high, so I tried and I modified that, and that gave me 9.3. So I'm going to go ahead and say that that's to the nearest tenth, and then again, rounding to the nearest whole number is 9. Okay. We'll take a look at one more. I think I'm going to actually go back and get this one, which is the square root of 227. So again, looking at my table, square root of 196 is 14. And the square root of 225 is 15. So again, 227, that's right around, that's really pretty close right here. So I'm going to try a little bit before 15. Oh, let's do an estimate. Let's try 14.8 maybe. Let's see what we get when we do that. So the multiplication there. Let's see, 32 and 6 is 38. 32, 16, 17, 18, 19, 5. Last bit of multiplication here. Uh, 219.04. I'm looking for something a little bit more than that. Actually, you know what, you guys? I just am catching my mistake here. Sorry about that. 227 is actually right past 225. Sorry, I was going on the wrong end of things here. So I'm going to try 15.1. Let's see here. Again, errors are made. That's okay. Errors allow for us to learn. 228.01, that sounds pretty good. All right, so to the nearest tenth, 15.1. To the nearest whole number, 15. Good, so I'm going to take a look at these last couple of word problems. First one, estimate the length of a side for each square. So if you remember, whatever the side length is on a square, it's the same on both sides. So the area length times width equals 40. Please do not make the mistake here and say that it's 20 times 20. 20 times 20 is 400. Okay, what we're looking at is this is an exponent. X squared is equal to 40. So we have to take the square root of both sides. And now we're estimating, since it's not perfect, square root of 40. I'm actually taking a look up here at this first example we did. 6.2 times 6.2 was 38.44. I'm going to use my knowledge there. I'm going to actually try 6.3 in my scratch work and see if that works out to give me something close to 40. So let's see what we get when we multiply. 39.69. Oops, scoot this up. That's actually quite close. So I'm going to go ahead and take that as my best guess, my best estimate. So 6.3, and again, I'm going to put those approximate signs, approximately 6.3 inches for each side. And our last one, the formula S equals the square root of 18D can be used to find the speed of the car, S, in miles per hour, when the car needs D amount of distance to come to a complete stop after slamming on the brakes. If it took a car 12 feet to come to a complete stop after slamming on the brakes, estimate the speed of the car. So we're solving for the speed, that's S. The amount of distance, where was it, 12 feet? So let's take a look. S is equal to, I'm going to do a little bit of scratch work. What is 18 times 12 underneath the radical sign? 216. The square root of 216. So again, if we take a look at our perfect squares, 216, we've got 14 squared is 196. 15 squared is 225. So 216 is going to be somewhere on this end. It's above 0.5, so I think I'm going to try maybe 14.8. And actually, you know what, you guys? Take a look at this. Thank goodness I didn't erase my scratch work for errors that I did. Up in example number 4, remember when we tried 14.8, that gave us 219.04. That's actually pretty darn close. I'm going to go ahead and use that as my approximation for the answer, about 14.8. And again, we're talking about the speed. So that's in miles per hour. So as you take a look at this assignment, again, you're going to see that you'll be asked to round to the nearest tenth and also to the nearest integer. So just make sure that you read those directions carefully. If it doesn't say one specifically, we're going to go ahead and include both. All right, you guys, this is the notes for this week, the 2 lessons for you to work on, and I will see you next week for the next couple of lessons. Have a great day.